Red, yellow, green, blue. You walk past them every single day, but these colors are not aesthetic choices. They aren't random, and they certainly aren't just about neighborhood decoration. They are a coded language written by the National Fire Protection Association. When a fire truck pulls up to a burning building, the driver doesn't have time to test the water pressure. They need to know the flow rate instantly. If they hook a high-pressure pump to a weak hydrant, they could collapse the city water main or starve their hoses of water while the building burns. To solve this, civil engineers follow the NFPA 291 standard. The color of the bonnet, the top cap of the hydrant, reveals exactly how many gallons per minute, or GPM, that hydrant can provide. First, you have red. This is Class C. It is the weakest link in the system, providing less than 500 gallons per minute. It's adequate for a small residential house fire, but if you see a red cap near a skyscraper, that is a problem. Next is orange. This is Class B, providing between 500 and 1,000 gallons per minute. This is your standard flow for most suburban streets. Then we step up to green, Class A. This hydrant pumps between 1,000 and 1,500 gallons per minute, usually found in industrial zones or dense city blocks. Finally, there is light blue, Class AA. This is the super hydrant. If you see a blue cap, it means the hydrant is capable of delivering over 1,500 gallons per minute. But color isn't the only engineering secret here. The internal mechanics of the hydrant actually change entirely depending on the climate where you live. If you live in a warm climate like Florida or Southern California, you likely have wet barrel hydrants. In these designs, the water sits inside the hydrant right at the surface, ready to flow the moment the valve is opened. But in the north, where temperatures drop below freezing, a wet barrel would be a disaster. The standing water would freeze, expand, and shatter the iron casing like glass. So northern cities use the dry barrel. In a dry barrel hydrant, the visible part above ground is actually completely empty. The main water valve isn't at the street level. It is buried 6 feet underground, well below the frost line. When a firefighter turns the nut on top, it rotates a long vertical steel rod that travels down the center of the barrel to push the underground valve open. Crucially, when they close the hydrant, a tiny drain valve at the base automatically opens. This dumps any remaining water in the barrel into the surrounding gravel bed, leaving the hydrant empty and safe from freezing.